Hello everyone, our discussion for today is on plane chess. But before we start with our discussion, let us identify the learning objective for this chapter. So number one, distinguish the difference between the global and local coordinate system. Two, learn to derive the member stiffness matrix for a truss member. Three, learn to transform the displacement from local coordinate system to global coordinate system. 4. Learn to transfer forces from local to global coordinate system. 5. Learn to transform member stiffness matrix from local to global coordinate system. 6. Learn to assemble member stiffness matrices to obtain the global stiffness matrix. 7. Learn to analyze plane chess by the direct stiffness matrix. And 8. Learn to solve plane chess problems using stiffness matrix method. So before we identify the difference between the global and local coordinate system that we will be using in this chapter in the analysis of the problems, let us try to define what is a plane truss. So a plane truss is defined based on our previous learnings in theory of structures. A plane truss is defined as a two-dimensional framework of straight prismatic members connected at their ends by frictionless hinge joints and subjected to loads and reactions that act only at the joints and lie in the plane of the structure. So basically, a plane truss, it is a two-dimensional framework that is being supported by a hinge support, can be a roller somehow, and that is subjected to an external load, and of course there would be reactions wherein they act at the joints and lie in the plane of the structure. So the objective of this chapter is to develop the analysis of plane trusses based on the matrix stiffness method. This method of analysis is general in the sense that it can be applied to statically determinate as well as indeterminate plane trusses of any size and shape. So as mentioned, we are going to begin the chapter with the definitions of the global and local coordinate system to be used in the analysis. So what's the difference between global and local coordinate system? Of course, in our previous learnings, in our lower years, we were introduced to one coordinate system, which is that is the rectangular coordinate system or the Cartesian coordinate system. So now in matrix structural analysis, you will be introduced to two coordinate systems. We have the global coordinate system and the local coordinate system. When I talk about global coordinate system, this is also known as structure coordinate system. So how do we identify the global or structure coordinate system for a plane truss? So for example, this is your actual truss. Of course, this actual truss is subjected to an external load. So there is an external load acting on the plane truss. You have 150 kips. It makes 30 degrees with the horizontal, and of course you have a vertical downward force which is 75 kips. So let us identify our global coordinate system. So if we're going to identify now the global coordinate system, okay, let us try to identify how many members do we have on our plane truss. So we have 1, 2, 3, 4, 5, and 6. You have 2 horizontal, 2 vertical, and 2 diagonal. So they are numbered enclosed with a rectangle. How many joints do we have on the plane truss? Let us count off. We have 1, 2, 3, and 4. So you have 4 joints on the plane truss. It is being numbered enclosed with a circle. So for this one, if we're going to identify our global coordinate system or the structure coordinate system, so let us have this as our origin. If this would be our origin, so we have here, you draw a line horizontal, that can be our x coordinate system. That can be our x-axis rather. Then you draw a line perpendicular to x, so that is now your y-axis. So basically, we have identified now our x and y-axis for the global coordinate system. So this is being known as global coordinate system or structure coordinate system because we establish our coordinate system for the whole structure. Now, what is local coordinate system? Local coordinate system is also known as member coordinate system. So for the local coordinate system or the member coordinate system, we consider the coordinate system for each member. So let us have an illustration. Let's have this member 1. Member 1 is in horizontal direction, so you draw a line along member 1, so that can be your x. You draw a line perpendicular to x, that is your y. Since this is member 1, so you can call this as x sub 1, this is your y sub 2. So we have now identified our coordinate system for member 1. Let us have member 3. Member 3 is a vertical member. So let us identify our local coordinate system or the member coordinate system. So you draw a line along with member 3. For the author, the orientation, you call this as x, and you draw a line perpendicular to x. This can be y. So this is now your local coordinate system or global coordinate system. So this is the x-axis and the y-axis for member 5 based on the orientation of the author. So let us have the diagonal member. Let's have member 5. Member 5 is in a diagonal position. You draw a line along with member 5, that is your x. You draw a line perpendicular to x, that's 1, that is now your y. So we can term this as x sub 5 and y sub 5. So you have now your coordinate system for member 5. So we have now established our coordinate system for member 5. So we have identified our local coordinate system for each member. So basically, we now identified what is a global coordinate system and what is a local coordinate system. So next to this is the degrees of freedom. Thank you.